I'm going to be presenting on my work. This is basically what I'm working on is utilizing container technology, and we'll talk a little bit about. We'll get some terminology out of the way here, and we're utilizing that technology to improve classroom as well as commercial productivity. And there's some specific scenarios that I'm covering in this work. So the overview is what we're going to be talking about. We're going to be applying the Docker container system, which I'll talk a little bit more about, to various use cases in education and commercial interests. We're going to do this, a lot of this we're going to be doing this using cloud resources, so this is all going to be running in the internet. So eliminates the need for people to set up local infrastructure on their laptops and all that kind of stuff to get things going. I've written some software called Academic, which I'll talk about. This application basically provides the infrastructure and all the orchestration of all these technologies and provides a user interface for people to work with it. And one example that we can use for a commercial scenario is, well, we're just calling it ETL agent right now, but this is where we're applying the same technology to a commercial situation where we're dealing with data being loaded into a data warehouse and being submitted by users and loaded through containers. To get started with, we'll talk a little bit about what this is trying to solve on the academic level. In a lot of computer science courses, anybody who has taken a course or taught a course will probably notice that one of the biggest challenges is getting software set up. So you have a certain stack of software you want to use, say it's SQL Server or Python, and everyone's going to bring in their own laptops, and everyone's going to have different environments. Some people are going to have Mac, some people are going to be using Windows, some people are going to be using cheap laptops, some are going to be using expensive ones. And you can spend a lot of time just getting these things to run on people's computers, and sometimes it just doesn't run. So, for example, we have a lot of trouble with Mac users when their SQL Server assignments come up because there is no really good management tool. There's no like SSMS for the Mac. That's one example. This is actually not uncommon to see this take like an entire week. Sometimes the first week or two, you're just spending dealing with these things. And as you add more pieces, as you go through the class, you spend more and more time dealing with these sort of issues. And also, this is also distracting from the student's angle. So they're worried about getting their assignment done, and now they also have to deal with, my computer's, my SQL Server isn't running for some reason. I can't figure out why. And arguably, if the goal of the course is writing database scripts, managing infrastructure is kind of out of scope for that. But when you run this stuff on your own machines, unfortunately you have to deal with that. And that's one of the big things that we're trying to solve with this software. The solution is that we use containers. So we'll talk, I guess, like I said, we'll talk about Docker in a second to get more specific about it. But containers in one sentence basically allow you to wrap up an application in a single unit and then run that application anywhere where Docker is supported. So we can use this technology to set up environments for students to run the software that they need, and then these environments will run in the cloud rather than on their own machines. So they don't even have to worry about installing anything on their machine. The ultimate goal of this project is that all you need is a web browser. You could go to a public library, or you could go to your grandma's house, and you could be doing your SQL Server or your Oracle homework no matter where you are, as long as you have a web browser. You could even do it on a tablet. And, of course, this will remove a lot of the burden that we just talked about on getting these environments set up for students and for instructors. And also, because this will use the software that I've written will kind of wrap around all these technologies, students also don't even have to learn about Docker and virtual machines if they choose not to. They can literally just click a button and have everything they need set up for them. So I'm going to cover a little bit of foundational stuff here, and you probably all have heard of a virtual machine, but I'm going to just talk about what we need to compare it to Docker containers. Virtual machines are basically simulations of an entire computer. So when you bring up a virtual machine, you have a certain amount of memory, a certain amount of disk storage, and you have virtual devices. You might have a virtual keyboard that feeds an input from your computer keyboard, or you might have virtual sound and video hardware. And you're running an entire operating system in a virtual machine. So when you think about an operating system like Windows, it's a pretty large product. A fresh installation of Windows is maybe 12 to 15 gigabytes in size. For each virtual machine, you need that entire piece of software, that entire infrastructure. And so VMs are very, very, very useful. They've been around for, technically since IBM did VM technology back on the mainframes, but in the PC space, they've been around since the late 90s, and They've been VMware, of course, is one of the big names in virtual machines, but there's a lot of other options now. There's VirtualBox, which is done by Oracle, and Microsoft has their own solution.
So what is the advantage of using this versus virtual machine?
We'll get to that on the next slide. So there are for the one advantage of a virtual machine is that it's an entire computer. So for the most part, you can do just about anything you can do on a regular computer on a virtual machine. There are some exceptions. For example, it can be tricky to run virtual machines on virtual machines. That's not impossible, but it requires a little bit of extra effort to get that kind of thing going. And certain applications like, say, gaming or video editing, those tend to struggle with VMs just because of hardware limitations, because you're working with virtual hardware, not real hardware. But for the kind of use case that we're looking at here, virtual machines are a good solution to get started with, and that's actually what a lot of students will do right now. Is they will, say, a Mac user will install Windows in a virtual machine, and they'll load, their SQL Server and their SSMS and everything into that environment. But the downside, of course, as I said, is that that's pretty resource intensive. So if you've got a relatively low-end machine, you may not have enough resources to run, or enough storage space or whatever, to run all of these tools on one machine. So where does Docker fit in? What is Docker compared to virtual machines? So the key difference with Docker versus virtual machines is that Docker is an application-level isolation technology, whereas virtual machines are kind of like a machine or an operating system-level isolation. So with containers, which Docker is possibly the most popular implementation of that, there actually are other implementations of the technology as well. But containers are defined by the fact that your operating system, so usually we run these on Linux, but you can run them on Windows as well. The operating system is still doing its job of memory management, I/O management, security, all those things that an operating system does are still being done by the operating system for all the containers. It's just that the operating system is now aware that these containers need to have isolation from each other, and it specifically implements that isolation at an operating system level. So to step up to step back just a little bit there, an operating system, in order to run containers, the OS has to be aware of containers. It has to know how to start them. It has to know how to isolate them. Whereas virtual machines, your operating system doesn't necessarily have to know anything about them. It can just, because it's running an entire virtual computer. One of the advantages, though, is that Docker containers do bring along any libraries or software requirements other than the operating system. So if you have, say, your standard C library and you have this old application that requires an older version of that library, well, that can be a hard thing because you have one version of that library on your system and you don't want to run an old version and try to deal with running it alongside. Well, with Docker, the only thing that you're sharing is the operating system and its functionalities, but things like libraries, things like all those things are isolated. So you can bring along...
How we call these libraries?
What's that?
How we will call these libraries?
By libraries, so that anything that a program depends on to run, right? So, and there's a lot of issues that come up with.
Select certain libraries, we don't get all.
Exactly. So a container can only bring along what it needs. It doesn't have to bring along. So if you have a system with 10 different applications on it, and all those applications require different software libraries to run, you're just going to have this hodgepodge of software libraries sitting on your system. Whereas if you use containers, each container has exactly what it needs to run that application and nothing more. And this, of course, has some security benefits. So you have a lot less potential for a vulnerability in a library to get into your entire system and start causing problems. Of course, it could get into one container, but from there it wouldn't be able to jump out and start messing with other stuff quite as easily.
What about the performance?
Performance is actually relatively equal. Because you're not really virtualizing an entire computer here, the applications are really what you're doing is you're virtualizing things that you might ask an operating system to do. So things like show me what files are on the system, give me some memory, connect to a network. These are all things that applications ask the operating system to do. And when you use container technology, you're just adding a layer on there, so that way the operating system says, oh, you're running in the SQL Server container, so I'm going to show you this view of the files on the system that only includes the SQL Server files and the libraries that go with that. You're not going to see the files that go with the Oracle database server or the ones that go with the Nginx web server. So really, that's just why I say it's an operating system level. It's an application level isolation technology, because it's really that applications, it's intercepting anything that an application asks the computer to do for it, the operating system to do for it, and that's how we get the isolation. Whereas with a virtual machine, it's at a higher level where every single thing that happens is going through that extra layer. In this case, if an application is doing, say, a bunch of math and it's just doing a bunch of data processing, your performance is going to be just about the same. Perhaps maybe like 0.1% less, but very, very minimal impact on performance.
What are your thoughts about this being leveraged in the security world? To me, containerizing it where you can structure permissions seems like it'd be very advantageous. What are your thoughts of this in the security world?
It actually is very advantageous. That's actually very true. When implemented correctly, of course, security is always kind of one of those things that you have to get it right. But when done correctly, this does mean that suppose an application has a vulnerability in it that would allow you into a system, even say root level access or sysadmin level access. Okay, so you could get into that container and you could start messing around with the files within that container, but you would not be able to jump off from that container and go to other parts of the system. So if you got into a database server, okay,
so
yeah,
security is better in this.
the
It's a
isolation.
layer of insulation, yeah.
It doesn't provide any more security than the application would normally have. What it does is it protects that application's, if there's a vulnerability in that application, it protects it from getting to other places. A really good example might be, say that your web server, say your Apache web server, has a bug in it that if you do this, you can get root access on the server. Now, in a traditional environment, you would say, oh, I've got root access. Now I'm going to go and start poking around the database because I now have root access. I can start ripping passwords out of the database, right? If you did this if you were using Docker containers, oh, the vulnerability got in, I can get into the root of that container. So, okay, I could vandalize the website, but I can't go to the database server because it's in a different container. It's isolated from that web server. So even though I got into that web server's container, I'm not able to go over to other containers on that system and cause problems there.
How recently this technology is?
Docker is relatively new. The concept has been around for a while. The concept of like sandboxing has been around for quite a while, and where you have this idea was actually available many years ago in Windows, where you could run an application in a sandbox environment. So anything that the application did wouldn't be stored to permanent storage. It would be stored like on a RAM drive, and then when you close the application, it would go away. And that was really useful for the security, for security testing and things like that as well. This is basically the evolution of that concept of being able to present different viewpoints of a system to different applications and provide secure isolation from other other applications. One other good point to make while we're talking about this is that you could implement this with virtual machines. You could certainly have a virtual machine for your web server, another one for your database server, and so on and so on. And that would certainly be just as secure as containers. The advantage that containers has over that is the resource utilization. Because you're able to share
multiple containers at the same time?
Oh, yes. So because you can share those operating system resources across all the containers on one system, you can have a container. I mean, for example, an Nginx web server container is like 1 megabyte. It's like 1 or 2. It's basically just the application. That's all it is. Whereas if you were going to set up an entire Linux machine to host that, you might be looking at, say, 500 megabytes.
Okay.
Plus, in that scenario, you would devote some memory to that web server. Say, I'm chunking off 1 gigabyte of my memory just for that web server. On Docker, you still get all the advantages of memory management at the OS level. So you can prioritize memory allocation. You can prioritize how applications swap off of memory out to disk. You can do all that at that OS level, but you're still getting all the advantages of, say, having separate virtual machines without the overhead. And in fact, on the second slide, I actually explain here some of the differences between virtual machines. And I think I just went over all of these basically from your questions.
Oh, that's good, yeah. It's good.
Mm-hmm.
Right, so they're implemented basically what are called namespaces. So a namespace is a specific view of the operating system and all of the stuff in the computer from the viewpoint of an application. Here's another example of where we can do isolation is networking. All these containers that we run, they each get like their own virtual IP address within this virtual network. And then the OS decides what can get out onto the internet. You can do firewalling at the container level. So, for example, you can say, a database server. Well, we don't want that accessible to the internet at all. We don't want anybody to be able to directly hit a database server. So that database server, it is listening on the network interface, but that interface is completely isolated from the real network interface, the one that's connected to the internet. And in that instance, again, even getting into the web server, well, you can't jump from there over to the database server because it's not even listening on the network interface at that point. So that's another security advantage. Now, for this specific application, for this academic system that we're talking about, VMs still do play a role. And the role that they play here is for a user interface, because Docker, for all of the great things it does, unfortunately is not, because it's an OS level isolation, it still doesn't have the ability to do, say, GUI-based applications with a user interface on them. So things like SQL Server Management Studio or SQL Developer. The isolation is great for security, but it can present some problems. Say if a student needs to store the script they wrote, so they can email it somewhere. Well, then we have to deal with what holes are we going to punch through the container to allow storage through. So virtual machines, also because they are an entire computer, from the viewpoint of a student, it's just like another computer. And I'll show how we can do that. So what we do is we can pre-build a virtual machine that has all the development tools on it, not the servers, but the tools. So things like SSMS or Oracle SQL Developer by Oracle, or PyCharm, any of these tools that are used by the developer, but the servers themselves, the actual servers, can still be running in Docker containers, and you're connecting to them from these tools. And that's actually a more realistic use case environment, because very rarely, other than maybe in a developer context, are you going to be running a server on your own machine. So let's talk more about this academic portal. I kind of cobbled together this name, Automated Course Assignment Deployment Engine for Management of Infrastructure in the Cloud. So, we all see these fun acronyms, so there's one for you to add to your list.
I was looking for the name, and he came up with academic.
Yeah, this is very good. Yeah.
So what I built here is basically it's an application that has multiple pieces, and this provides orchestration of all of these things we just talked about, or containers on Docker, virtual machines, and cloud infrastructure. And it brings all these together into a user interface that students can log into and basically have a one-click experience to get the things that they need. So we see that the students will they'll access assignments, and an assignment is basically a predefined container, a predefined set of containers, as a matter of fact, and we can do things like preload data. So we can have a database that already has tables and structure and data and all that stuff loaded into it. And you'll see this in a minute here, that we can have that already prepared. So when the student starts up their assignment, the database is there. It's already got the data. This eliminates things like running scripts. Oh, we got a blank database now. Oh, run the script. Oh, it didn't run. Oh, I forgot to drop the table. I have to restart my server. No, with this, just the server comes up with exactly the data that is required for the assignment already loaded into it.
Installing database and data.
Yep. So, and this happens. The thing about Docker containers that I actually forgot to mention before, that you'll see this, is they can start up extremely fast compared to virtual machines. A virtual machine is like installing an operating system. If you've ever done that, it's going to take you 30 minutes, and you got to run updates, and you got to install the application. Once these things are pre-configured and pre-built, you can stamp these things out like rubber stamps. You can just stamp them out, and these things can start up almost like within a second or two. So
it's almost like making a subclass of the operating system.
It basically is, exactly. That's a good way to put it. So you are creating. It is kind of like a virtual machine in that sense, because virtual machines can do that too. You can do clones of virtual machines, but even those take a while because you're copying the entire hard drive image. In this case, what Docker uses what's called layer technology. So what they do is there's all these different views of the files on your system. And depending on which floor you're standing on or which point you're standing at, you see different files. So in a Docker container, you have the layer that has the stuff in it, the SQL Server and all that. Then you have another layer on top of that, which is anything that you do within that container. So that's hidden from the other containers.
But this is not visible for the floor you are in.
The application running in Docker sees one specific view, but that view is not connected to any other. It can be based off, it can be built off of another view. So in this case, we don't have to copy that data to another place. We can say, here is the data, here is exactly, this is the starting point. So when student 1 brings up a container, we create another layer, and then anything that student 1 does is written to that layer. But then when student 2 brings up their container, they build a second layer off of that same first layer. So now it's like you have this row and then you have 2 above it. and then anything student 2 does is in the other layer. So it's basically only storing the difference between that base layer and what every student does. So it's very resource efficient as well. You can store this. I think all of the containers that I've built, which is like SQL Server, Oracle, and all this stuff, just a baseline setup is like 3 gigabytes. Which
So
compare that to
the
Windows.
application, the container will be available to others?
The container, in a sense, yes, but the image is available to others. But each person who runs it has their own copy of it. From their viewpoint, it's like a copy, but from the viewpoint of the server, it's a lot faster.
Similar to the virtual machine.
Right. So it's kind of like you don't have to. It's kind of like if you have a book and you're just going to write down the changes. You're not going to write down. You're not going to take the book and make a copy of it. You're just going to write down on page 3 I changed this word. On page 7 I changed this sentence. And then somebody else is going to edit the same book and do the same thing. So each person has a different set of changes, but those changes are not rolled back into that base image.
Original one.
Right. And then actually the way this works is when the student is done with the assignment, we just destroy the change. We just destroy that differencing image, and then they can start over. So if the student messes up, let's say that I dropped all the tables. Well, rather than having to run a script and go, I didn't drop all the tables, instead they just drop the container and bring it back up, and it comes back with a fresh set of data.
Oh, okay.
Here's the use cases that we're looking at. So, and this actually, like I said, does extend into commercial use cases. Automatically provisioning these development and learning environments, and preloading the assignment data, so the database data, which we just talked about, and allowing students to manage these things on their own. So I'm going to talk a little bit about Azure here because the original implementation of this was using Microsoft Azure because they're a cloud-based, they're a big cloud offering of all kinds of services that you can do on the internet. And one of their services is that you can run Docker containers there, and we've actually have this running. So the student can sign up for Azure. Every student at the universities in Mid-State, they get like $100 of free credit to use with Azure. And these things are not.
Is this for a year?
I don't know if it's per year. I think it's forever. I think it's just. But the cost of these containers is relatively low. I believe running a container like that would be configured based on the needs of these assignments for 1 month would cost you something like $10. So that's if you left one of them running 24/7. You'd pay $10 a month. But that's another thing about containers is you can bring them up and take them down as you need them. So when you're not working on your assignment, you can take the container down, and then you're not paying for it.
Okay.
For a student here, I pass the name every year, and they'll get access.
Okay.
Yep.
So is it
But
based on...
once they leave the school, it's not.
They are not there.
No, but they can, and we have a couple students, including myself, who do. You just put you can pay for it out of your pocket as well.
Right.
Oh, okay.
It's
And,
pennies,
you know,
it's not that much.
Yeah,
So it is part of the education in the school?
Yeah, that's...
they get
Yeah,
$100
the
of Azure
student
credit as part of being a part of the school system.
Right.
So.
You have to.
And then there's a couple commercial applications. One is that we're already doing right now is we're using the same infrastructure to do ETL tasks. So when people upload, for example, Microsoft Excel files, the same system kicks off a Docker container that takes that Excel file and does all the processing needed on it to load it into the data warehouse.
Well, the other
Bob,
day
you
that's
know
what I
about this. We've talked about this.
What's
so.
the performance on the whole process, the ETL process, would you say, compared to other methods without a container? Like time-wise is, I guess, what I'm thinking.
I would say, the performance is going to be about the same as doing this just like by having an exe file and just running it. The advantage of the container is, again, the isolation, but also just, the infrastructure. It means that we can just start stamping out more ETL-type applications as they come up. Oh, now we need to do access files. Oh, here's another file. We'll just create a container that has that application in it instead. And also it gives you some really nice parallelism because the containers exist as atomic units is what I was looking for. And so we can run 5 containers on one machine, we can run 10, as long as the resources are there on that machine, we can run 100 containers on it. And it doesn't really give you a performance impact, but it does give you a security improvement. It simplifies some of the development side as well. So an example is when we wrote the tool that does the load, we can just say the file will always be /input.xls. And the container, since remember I said these layers, each one has its own view of the file system. So each container has its own view of what that input.xls file is based on when it was kicked off by the academic system.
Mm-hmm. Very cool.
So it simplifies development as well. And that's, by the way, the other use case that I'm looking at as a future for this is using this actually as a development environment. So you get a newcomer, they've got their machine, they've got everything ready to go, but okay, they need a database. They need the data, some demo data they can do. They need the front end API so that they can test. They need the back end API. They need all these pieces. These can all be put into Docker as well. And in fact, a lot of the development we're doing here is I've been pushing for Docker-focused development just for that reason. So everything can be immediately brought up for anybody who's, or you'll need to reset it. You broke your database again. One click to reset it.
But it is easy for the students that they use the seamless, the software.
Yeah, you'll see it. It's
Yeah. One of the neatest things I ever read about Docker was if you develop using Docker, it totally eliminates the common phrase, but it works on my computer.
Oh,
Because when you use Docker, you're running the same thing. Because remember, it brings along all of those dependencies, all of those libraries, all those pieces that are needed. It
but
brings
there
those
is
with.
no really learning curve for the students.
That could be assignment itself.
Ah,
It's all based on assignment. If the assignment
So-
is learning Docker, then it's assignment for the
But again, this does not require a student to know how Docker works. That's the advantage of this setup. Here's an example of some assignments that we've actually set up.
So
And
one thing here, let me add.
okay,
This semester, we're trying to have them to do multiple SQL Server on their machine. And you probably wasted 2 or 3 sessions. Because somebody gets it, somebody doesn't get it, and we're going to help
so
them. And when they don't understand it, they're trying to take the class time. I really lost at least 2 or 3 sessions because of that. Now for this one, they go to the website, run it, get it done, and after that, they can't even run it from their
any place.
from the tablet, from anything.
yeah, I've actually, if we have enough time, I've actually got a Chromebook here, and I'll show that you can actually do
It
your
really
homework.
works on it. It really works.
You can do your SQL Server homework on a Chromebook, which this isn't even Windows or Mac. I mean, this is Chrome OS, and
I'm
with
asking him also to know that so he knows. Right?
He will talk to you until tomorrow.
here are some sample assignments, some of the things that we've done. For example, a
I
SQL
need
Server.
myself to learn it too.
And then we have like an Oracle server. These are all, these entire server stacks are in Docker containers that we can start up in almost instantly. And the example that Cyrus gave is 2 SQL servers that we want to do an open query against, from one server to the other. And with this, we can bring that up in about
Did you
5
make
seconds.
it work for Macintosh, MacBook? Computer?
You'll see what I've done for that. The VM piece of it is there's still some work I need to do there before we can kind of go live with this for an actual class setting. Because right now there's just a single VM. So VM provisioning is one of those tough ones because there's really no way to speed up. Because like I said, you're installing Windows. So you can speed it up, you can automate it, but it still becomes like wait 5 to 10 minutes and then come back and your VM's ready. So there are some ideas I have for ways to optimize that further too. But right now for this demo, we just have a single virtual machine that will show. And then for one other example that I've been working with Silica on is using this technology for Spark. For doing data processing with Spark. And for that, we have a really neat web interface that they can actually write Python
You
code,
did it.
execute
You
it.
did it for the class already.
So they
You're
can
going to use it here.
write Python code, and they can execute it, see the results, and they can do all this from a web browser. So I'll just talk really quickly about the architecture of the application. It's a 5-tier application. We have a front end that's written in AngularJS. We have the API, which that front end communicates with. That's a .NET API. And then we have job control and batch processing agent. This is a key piece of this because this basically allows parallelism. So 5, 10, 15, 20 students can all be starting and stopping and managing containers all at the same time without the web UI just bogging down. Everybody.
There is limit.
What's that?
There is a limit, you said 20, whatever. There is a limit for the numbers?
Well, the limit is how many of these job control agents you run and what resources they have available. It's all resource utilization. So I mean, if you've got a super server with 72 CPU cores and 256 gigabytes of RAM and a couple gigabit networks, you can run 500,000 containers on that server probably. If you've got a laptop and you're trying to run this on with 4 gig of RAM and you're probably only going to be able to get by with 2 or 3 containers. So it's all just what resources you have available. You can't get around that part, but what you can do with Docker is minimize the amount of unnecessary resource utilization.
It doesn't matter what the student has because Azure server, but Azure server is depending on how much money I got.
Yes.
Yeah, so if you're willing to spend, if you've got deep pockets,
So
I
it's
think
all
the
demand type thing.
I think the biggest offering I saw from them was something like 512 CPU cores, 4 terabytes of memory, and like some number of hundreds of terabytes of disk. And this is something that costs you about $40,000 a month. But the point is, it is possible. With that, if you got that kind of money, you could run on that machine like that, or you could run 25,000. You could do probably all the CS courses around Minnesota on that server.
This would be good for industry.
Right. This is actually industry application.
This is a good segue into a question that I have. So imagine with ACS Group, 1,500 subsidiary companies, all working on their different projects. Data centers, server layout, architecture is going to become a real problem real quick because, as you're saying, this could be a solution to this, and this is going to really.
It requires more research, but I think we have the seed for this now.
Oh yeah, that's.
I have
from like my standpoint, I know like a follow-up project I would love to see, or innovation I'd love to see from this is how could we do that with a whole project ecosystem set up, containerize the whole code base, applications, and systems we use all together. So that way we could have dynamic efficiency between all of them, containerize that and deploy. So
we can already do that with what I have. We can do container stacks. So and all that's like the one here that we're doing with the one that we're doing with like 2 SQL servers.
You can think of this kind of stuff, but that's our purpose is to come up with ideas.
So
IT ops is a huge, important part of innovation.
Yeah, I just sent an email pretty much saying our group must have that infrastructure component, and this is going to be a major thing that we're going to have a solve for, because when we start deploying this across projects, each project wants to be in their own independent physical container, which this solves this.
Right.
But at the same point, we can also keep costs low from an infrastructure perspective by gaining on the efficiency that this can leverage.
One of the other pieces that I've actually started to work on basically on a resource management algorithm. So the idea is, let's say you have 10 Docker servers, you have 10 machines, and they could be all different sizes. One is just a little 4 gigabyte, 120 gigabyte storage, just a little VM. On the other end of the scale, you've got one of these massive 96 core machines. This algorithm will be able to intelligently allocate based on priorities and like dev versus prod. And so you could just, from the user angle, I want a new infrastructure. I want an entire infrastructure for a project. I want all these pieces. It would figure out which server has the most resources available. That's the best place to put that. Assign it to that server, and then bring it up on that server. And then in the end, you just get the URLs you need, the IP addresses and the web URLs.
The maximum time we have is 10 more minutes.
Yes.
Okay. All right. Well, then let's hurry up so we can.
Interview coming.
So let's hurry up then.
It is very good.
This is
long term is the answer. I know we're facing from a commercial problem.
I want to try to at least get to a quick demo. I'm glad. I'll explain a little bit. I'm actually glad because what I'm doing now is I'm using direct Docker, so I'm not using Azure Docker for this demo, and there's a reason for that because Azure is, for some reason, Docker deployments on Azure take like 5 minutes, whereas running them on your own instance of a Docker host takes like 5 seconds. So you'll see. Here's a quick diagram of the architecture. Basically, everything is done through.
This is from your machine.
Yeah. So the student is over here on the left, and then everything goes to the internet. They are basically hitting the API to control it, and then they're actually hitting the resources themselves when they do the work. But also, you could go straight from the API to the resources, as you'll see. It's a batch processing model, so this actually kind of is a throwback to mainframe days. So you queue a job. When you want to start a container, it queues a job. The agent picks it up, runs the job, and produces the results and puts them in the database. And we can have as many agents as we have resources for processing these jobs. So when you get an environment where you have 10,000 students or 10,000 people all wanting to do this stuff, as long as we have enough of these agents sitting there and enough resources to do it, we can do that. We can handle it. The architecture already has support for that. And the plugin architecture is extensible, so I've actually written 2 versions. I've written one that does Azure and one that does just Docker on the local machine, like I'll talk about when I demonstrate it. And there's also no reason we couldn't write a plugin for Amazon EC2, for example, or Amazon AWS, or Google Compute Cloud, or if you have an on-premise data center, we could run it there. So. And from the user side, basically, it's the student will log in. For the Azure example, and I'm not going to get to that today, but the Azure example is they would go to the Azure portal and present, get a token from it and provide that token to the system so it has access to their account. But we're going to skip that part. And then they just basically click the assignment. It starts it up. They get the information they need. They do the work. When they're finished, they shut it down, and they're good to go.
They do this for also 210 programming class. So you
you
can
told me
actually
that,
grade that versus what you've done.
And that's in the future work. So, and then here's an example. And I don't know if I'll get to this today. I was kind of disappointed, but I'll at least try to show the idea of what we can do with
I give you 5 more minutes, okay?
web browsing.
Like
Okay,
15
yeah.
minutes, I gotta quit.
Okay, well then, and then the academic, we have applied it, and I've already talked about this, so I don't have to spend too much time on this slide. That we've already talked about how we have applied this in a commercial
But
environment.
you didn't create.
It's an acronym for the commercial application, as you did with the
They
academic.
still use academic.
It's the same agent. Basically, the difference is the front end and the back end, but the same agent is running to do all these containers and all that, and
I'm
it's
gonna ask
still.
you to make an explore or something.
Yeah, this is what
Yeah.
I was.
You gotta come up with something that has an explore in it.
Yeah, there's a commercial side to this that, like,
See,
seeing
yeah.
this idea, I would love to see a proof of concept in a couple areas with this.
Maybe
because-
medic.
Okay, so let's demo it.
Academic.
So I'm going to pull over here to the browser. I've already got it up. I'm going to save you some time. This is. Would you seriously
As
go
if
away?
I was a student, I go to my Azure and connect to the website, and then come here.
The thing, by the way, academic itself is hosted in Docker. Everything you're seeing right now is itself running in Docker. So it eats its own dog food, as they say. Everything. So that means we can actually bring up this entire infrastructure with one click. We could do like academic in academic, you know.
So that's interesting for a project setup across
Yeah.
the commercial world. If
So I'm
you
gonna
need to
log
spin
in.
up a new project or a new environment, you spin up a container, it's a starting point, it's all there. Yeah.
So this example, this front end is obviously an education front end, but the front end, the reason I did it as a 5-tier application is because each of these pieces can be independently replaced. So the front and back end can be replaced, and that's exactly what we've done here at Hucktief. We are using we're integrating it with the front end that those guys are working on. And and then we also have the back end. They're integrating with the standard, with the database layout and everything that this expects. So I'm just going to show you really quickly. Let's say that we are going to be working on a fuzzy assignment. So we need the FAOES database. So I'm going to click this button and watch how fast this is.
This is a few
Provisioning, please wait. We got it. This is the
That's
information
starting
that
at
we
the
need.
database, loading the script and come here.
This is the information that we need right here to connect. There's the host name. Here's a connection string. Here's the port number. And it actually generates a password. If I bring up SSMS. And the other one I want to show is the Spark
It
one.
just
'cause it's-
is installed SSMS, brand new.
yeah,
not SSMS. I installed the SQL Server.
SQL Server, sorry.
SSMS is already on this machine. But
it's
222.
beyond impressive.
And another
SQL
example I
Server.
have, it brings 2 SQL Server and 1 Oracle.
If you think of how painful it is every time people
Yeah,
have to
they
spin
couldn't
up
All
a
right,
server.
so hang on, I'm going to connect to that
It's a long
SQL Server.
process.
Is here, look.
I've connected.
This is the future of IT ops, is setting up infrastructure.
Look at this.
like
Look at database. Click on database.
And there's the database.
FOES is there.
E
It's all there.
Is it there?
And look at all the fuzzy
Is there
tables.
data populated
All
in those
done.
tables
Yep,
too?
the data's in there, yep.
Yeah, this is.
Do you know how much time
Interesting.
a student takes to get the SQL Server running and then get the
Well,
things
from
running and get in trouble to get me why this table doesn't work? What they
From a commercial side, imagine projects groups wanting to spin up something for their opco. They can just spin this up. They have their own environment that's walled off from others, so it
Yeah.
meets all security constraints.
This is neat.
And then
Yeah.
I'll show this really quick. So if you're on I'm on a Windows machine, so I have SSMS locally. But let's say I'm on a Mac, and I want to develop. I'm a student. I want to develop. I basically click this. It gives me a web portal to a VM. And now in my browser, here's a VM. Look how fast that came up. And now I can run SSMS in that VM. And now I can connect.
Mac doesn't support SSMS, so we have to go to the virtual memory to do it. And the student still someone cannot run this. But if they go to get help from Plain, they can do it. We like to make that also as part of that interface. But we are so much depending on people having a VM in their machine. And
So then
trying
here
to
I
create
can
a
actually
VM
take a
for
look
them,
at password D.
It takes a little work.
Yeah, this has so many use cases in the commercial side. Like, even thinking back at my time at Hayworth, this sort of saved us knowing how frequently servers are used and how when you allocate resources, it's pretty much lost in the resource itself. this could have given us 4 times as much effective resources.
And so now here you see in the browser, I have brought up SSMS. Here's my FAOES, and just keep in mind it is in a browser. And
Macintosh.
yeah, I can do it on this Chromebook. I've actually done it on this Chromebook. I pull up that VM, and I'm seeing it in the browser on this Chromebook. So this totally eliminates all of the issues of, well, my computer doesn't have enough memory. My parents will only buy me a cheap netbook. It has 2 gig of RAM. I can't run
Then you
SQL
can
Server.
run it.
Well,
this
you'd run it on
summer-
here.
This summer we're going to do a 640 class using this from online.
So basically, what we do to set these up
That's basically
is,
support what he was like.
Cyrus, you just you provided me with the scripts to build those databases. I basically build those databases. I deploy them as Docker containers, and then program those into the database for the academic portal, and then everything is.
They can go and
everything is
start
there.
work on it, use it.
Yeah.
There
And so
is
you see,
assignment
so
how to install, but
The
that's-
potential for how fast we can
Only
bring
one
things
second.
up. You saw, we brought up a VM and the SQL Server in less than a minute. And by the way, when I'm finished, I go over here to assignments, and I'm just going to use the one down here. I can hit stop all assignments. So once I've clicked that, it's now shutting down that SQL Server. This is not as big of a deal with this setup because it's self-hosted. But if you were to do this in Azure, by bringing this
I
down,
don't
you're no
want- I
longer
don't want to
paying.
pay for it, no.
Yeah. So it's now shutting that down.
Question for you, and this may be
Container
something
stuff.
something you guys haven't seen. How does licensing cost apply with spinning up and shutting down these types of systems? So, for instance, we need to pay for SQL Server licenses. We need to
If
pay.
you're in Azure, the whole package is your cost.
You can't.
Right,
Yeah.
but
You,
Azure, in my opinion, is very expensive. You could also have an on-prem data center that leverages this. This is what Azure is doing.
At
Is
that
it's spinning
point-
this stuff up. I don't know why we wouldn't do it ourselves because it's by far cheaper,
Well,
especially with the
we
use
don't
cases
have
we
that
may
kind
have.
of capability yet.
I
We
think
have
that
servers
I
and
don't.
that.
I'm just thinking out
licensing
loud
is a little
long-term.
licensing is a little out of scope for this demo, but I think what we would do is you would just buy enough licenses because they can be moved around. So you would just, as long as you have, because basically Microsoft, Oracle, all these guys, all of their licensing today is kind of on the honor system / backed by audits. So as long as you have enough, as long as you've paid for enough instances, it doesn't really matter where you put them. Because Microsoft themselves provides Dockers of SQL Server. This is something that they themselves provide, and they basically say, just if you just put I have a license equals yes, then it just runs. It does it, Or for this example, we're using the developer license, which is free for non-production use
You
anyway.
have 2 minutes
so.
to show your code as well. The code in the back behind all this, and let's let them see that this is not just a plug and play thing. He has a lot of programming.
Yeah,
I
so-
believe it.
It's clear, yeah.
He has done a lot of programming.
Well, this type of setup is a lot like what Azure is currently doing with like their Microsoft's data center when they spin up new environments for people to use. This is what it's doing. Like at a high level, like not this exact code, but this is very similar to what it's doing. But that's incredibly valuable because instead of having to pay for this as a service, you could do your own on-prem cloud.
Exactly. And so what you actually are doing here is I'm basically providing that automation tooling that Azure is so well known for, but it's something that you can just, here is the code repositories here. If I go up to the branches, we see we have basically those 4 pieces, and that
TFS.
those 4 pieces here, and then that 5th piece, of course, is the is Azure or whatever your host is. So here's our back end, our front end, there's that user agent that does the batch processing agent rather. And if I got 2 more minutes, I'm going to flip back over here for just a second and say, one of the future goals of this for the academic side is assignment grading. So once you've completed your work, you could go back there and say, I've completed. It will go into your container, pull your database that you've worked on,
Code review. is
grade
very
it,
quick.
and then submit, and then produce a report for the instructor.
It's good.
So that means the code review could be part of it already.
Right. So the student
Yeah.
doesn't even have to do an actual log in the D2L and submit. Basically, they just get the container to a certain state. They say, "Oh, I have a script saved in my container, and I have the database. I've run that script on it, and the results are there." At that point, the academic agent will go in, look at the database, look at the
Run it.
script. Use there might be some fuzzy that has to go into this, and and then produce. And it's not going to give a final grade. It's going to give like a confidence score, and then of course the instructor is still going to do a manual review. But it saves a lot of. Even from the instructor angle, I imagine, you've got to have this database. You got to run the student script against it. Then you got to reset. Then you got to run the next student script. You got to reset. This can basically automate that for the instructor as well as the student. So the instructor can say, "I want to see what
This is
John
your
Doe did for his container," and it will bring up John
Flint.
Doe's container with the work that they did.
Flint, this is your PhD topic. all you gotta do is sign up to some PhD program.
And
get
then do
this
for the
completed.
instructor side, yeah.
Yeah,
And then of course
you're
instructor
done.
management.
You're done.
And the HTML5 VM client, I actually got that done, as you saw. I got a proof of concept of it, so that's not even future work anymore. And then, like, I want to actually register this as an Azure application, so you could spin this up as an Azure service.
There is
This entire infrastructure could be a one-click deploy from the IT ops side too.
The reason was future.
We have
because
lots
we
of
were
use
planning
cases
on
on
last
the
year.
commercial
Instead
side to
of
be discussing with
instructors,
this.
we have
There's a lot of stuff here.
Instead of instructors, we have containers now.
But I think this is a real, where I see this being really cool in the academic space is online courses.
Yeah.
Because it's hard enough when you have everybody in a classroom and you're trying to get everybody's environment working. Imagine doing this over the internet where people you don't even know what kind of machine they have. They got some Acer desktop in their basement that they're trying to do their work from. I mean, I see this for online classes in particular.
We're gonna try
These
this
one-click deployments of entire environments. And I mean, I know this has been done before, but I don't think it's been done to this level of integration. I haven't actually seen quite this much integration before. I've seen a lot of you can bring up a SQL server, but you still have to install SSMS. You still have to, So
The value here is
my goal
Like,
here is
for
to
smaller-
integrate as much as possible into one click. So yeah, the developer, the student, or whatever clicks one button, everything they need is ready for them.
for smaller companies. This won't have as high of a magnitude, but if you think from a commercial side, ACS Group with 1,500 subsidiary companies, each group wanting to have their own private ecosystem. Imagine three scenarios. One leverages Azure on the cloud. The cost of that would be insane. The second is each group has their own private on-prem servers, but the resource burn, the licensing would also be a staggering cost. The third now is this option, which you can containerize each of these groups, but keep down on the cost and server licenses between them.
Well, you
There's
could-
an immense amount of value that can happen.
What you
here
could
from a
do with this is
commercial
you could
side.
come up with a standard package. Say that you're deploying a new company. You could say they need this hardware. You could even have a standard package, and you could set that up with Dell or whoever, so they would ship you, say 2 servers and a switch and some connectivity, and you could preload all this stuff on there, and then they turn this on, log into this portal, and their environment's there.
Yeah.
It's up in less than a day. You're going to spend more time taking the server out of the box than you're going to spend putting the software on it.
Yeah, because they go to the website and just run.
Yeah.
that's great, Flint. It's very interesting.
And if they're working, he did it on his own. But if they're working off the Azure, the container opens up in Azure, and they are doing this stuff in a
Right.
database in
Cloud.
Azure.
So remembering,
So
I
the
built
machine
this.
has
I
nothing
built
to do
this
with
as an extensible platform, so we can certainly, we could write an engine to do this on Amazon AWS. If we have a company that says, well, that's what they have a deal with them or something, that's what they want to use. No problem. We can bring this up on AWS just by having a new plugin for the agent.
Well, I see it from a commercial side, cloud solutions like what Microsoft offers or what Oracle or AWS or anything, they're so expensive. And this gives the ability for us to build really our own cloud solution across
Another
the entire
option,
corporation. But that puts it on-prem with our own data center, but that's much more cost-effective than...
But another option, even if you're not looking at on-premise, if you look at a service like DigitalOcean, where they just basically give you a server. I mean, they don't do anything other than here, how much RAM do you want? How much storage do you want? How, here you go. Here's your server. It costs this much per month at flat rate. And you'll see that being done. And so then we could set this up as a pre-deployable image on, say, DigitalOcean. And so you get like a startup who they don't even have space to put a couple of servers. They're just working out of a tiny office. They could bring up a DigitalOcean VM for $100 a month and have the entire infrastructure on there.
Flint, you did a great job.
Thank you, that's great.
Yeah.
It's fantastic.
Congratulations. From my point of view, you have passed the long thing.
No, he is, I told him.
Does it depend? It depends on if you forget your password, right?
No. No, you did a great job, and it is very good. I'm proud of you. You did a good job.
This is truly exceptional.
Yes.
Just I gotta show this. So here on the Chromebook, I can click on this. Actually, can I hook it up? Does that work?
I see so many places in the industry too that something like this would cut down on costs dramatically.
Oh,
To actually demonstrate and show it all too, it's impressive.
screen mirroring.
Yeah, please do. Because
So this is actually on a Chromebook, as you can see, Google Chromebook here. And if I do that academic, I am now connecting to that virtual machine. There it is that we were running.
So if
and-
we have a Cyrus container, he will not forget
Yeah.
to come.
I am now on a Chromebook, and I am connecting to a SQL server. So I'm just going to connect to my own, because I don't have a. Well, actually, I'm going to bring a container up. Let's do it. Let's go over here and let's start up. So that's the other thing is the VM is independent of the containers.
This is very good. Yeah.
So the VM is running. I don't have any containers running. Let me bring up this one because I didn't get to show this one before. Is the Open Query assignment. So this is where we're going to bring up
You don't have a virtual machine in your system. You don't have to.
the virtual machines in the cloud.
Ah.
The virtual machines in the cloud. So here I have two servers. The connection information for each server, and these passwords are kind of they're randomly generated, but I've seen
so
worse
it generates
passwords.
for you.
It does randomly generate the password, so now I can connect to. Let's just connect to one of them, just so we can show it working. So it's actually going to be on
So
port.
you don't worry if you forgot your password.
Right. Well, if you restart the container, you get a new password. That's going to become a long-standing joke, isn't it?
No.
Okay, so now here I am on Chrome, on Google Chrome in a Chromebook, and I'm connected to a SQL server. Here's my database.
I tell you why I said that. I picked a new one. Because Shadi told me that Flint cannot. No, I'm talking about you. Shadi said Flint cannot do it. I said, yes, you said that. He will. What you said? Oh, okay. Tell me what you said. No, but he will not get your data back. So that's why I didn't believe him.
So there you go.
Oh, see?
So here you go. So see we're running it, and actually I can full screen this as well. If I hit this, I can full screen that, make it a little bit bigger. And so here we are running SQL queries on a Chromebook through a VM in the cloud with a container we brought up in 5 seconds. So I'm actually going to do one more thing. If you guys have
So you
another
said
minute.
the other one will take 5 minutes?
Let me start up the Spark one. This will start up just as fast actually. If I start up the Spark container, and this is what I worked with Silica on. She did a lot of the work on the Spark side, and then I just basically did the container work. There we go.
Oh.
We are up already. Let's grab this URL. There's some UI stuff that we need to work on. Like this should be a link, so you don't have to do this. But we can live with it for now. So I'll paste the URL.
So you can click it here.
Yeah. So I'm going to
it goes
log
right
in.
away. You don't have to copy it.
Ideally, yeah, you won't even have. You'll just be able to click the link. So here we are. This is Python running in the cloud. So I'm going to bring up the notebook with the Spark code. Here's the code. So we can preload the code as well. Like we can preload samples of code, and then we could say maybe your assignment is to take this and add something to it, or make a change to it, or maybe the code has a bug. It doesn't work. Your job is to fix the bug.
Or solutions.
Right. And so then if I click the restart and run button up here. Right there, that one. And so now in the background, there's our results from the code. This is all running in the cloud. Again, from a Chromebook.
That's very good.
And then finally, I'm going to come back over here. I'm going to go up to assignments, and I'm going to shut all these things down. Just click this. Now, anything that now again, this isn't costing right now, but if this were costing money, anything is now going to stop costing you. Now, of course, you lose the data. You do lose data. But one thing you might have noticed in that VM is it does. At least for this demo, I set it up to connect to MavDisk, so a student could save their data on Mav Drive.
Oh, in theirs.
So as long as they store their data on the Mav disk,
That's
they can bring the VM up and down at will because their data is safe anyway. So it takes it a bit of time to bring them down just because we have like 4 or 5 VMs running right now, or 4 or 5 containers rather running right now. But there we go, we're done.
Thank you. That's very good.
Fantastic work.